Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over a couple of practice problems where you are given the initial conditions of a reaction and you're given some equilibrium conditions, and you're going to be using an ice table to figure out what the other equilibrium conditions are in the problem. So and then we're going to use those initial conditions to figure out what the equilibrium constant is going to be. And so in the first problem, they give me a reaction. They tell me that carbon monoxide plus hydrogen gas is going to give me methanol, so gaseous methanol. And so they give me the initial conditions of the carbon monoxide. So they give me the initial concentration of carbon monoxide, 0.500 molar. And then they give me the initial concentration of H2, which is 1.00 molar. So they give me the initial concentrations of these two, as well as this one. So this is 0, so I don't have any product to start with. So these are the initial conditions that they're giving me. And they tell me at equilibrium, my carbon monoxide concentration is 0.15 molar. And that's all they give me in the problem. So what I do is I set up my ice table and I put in the information that they give me. So here's my ice table. And so I is for initial starting concentrations. C is for the change in the concentration, and E is whatever concentrations I have at equilibrium. So I take the information they give me in the problem and I put it in my table, and then I figure out like what needs to be figured out in the table. So I fill in the table by using stoichiometry. So I'm going to use what I know of the mole ratios in the between the substances in the equation. And so what you do is you start here and say, well, I know that I started with 0.5 molar of CO, and now I'm at 0.15. So here it dropped. So I need to figure out the change here. The change here is 0.35. So 0.35. So there's a loss. I'll put a negative there. So it lost 0.35 molar, or moles if you want to put it that way, since they're all per liter. It went down by 0.35. Okay, so this is going to be helpful, because then if I know the change in the carbon monoxide, then I can figure out what the change should be for these two based on stoichiometry. So since there's a 1-to-2 ratio between here, whatever I lose here, this is a reactant as well, so I'm going to lose here as well, but I'm going to lose double the amount. So here, instead of negative 0.35, it's going to be negative 2 times 0.35. Okay? So that's going to be the loss here. So if I start with 1 molar and I'm going to lose this, now I can figure out what the equilibrium amount for H2 is going to be. And so that's going to be 0.7. So I'm losing 0.7, and that leaves me with 0.30. So that's my equilibrium amount here. Now I can also do the same thing for my methanol. So between carbon monoxide and methanol, it's a 1-to-1. So since I'm losing 0.35 here, I'm going to gain that same amount over here. So since this is a product, I'm gaining product since I'm going from 0 to whatever it is. So I'm going to gain, since I lose here, I'm going to gain here. So I'm going to add plus 0.35 which means that the equilibrium amount at equilibrium for this is going to be 0 plus 0.35 is 0.35. So now I have the equilibrium amounts that I need, and now I got to set up the equation, the expression of the Kc value. So for here, the Kc expression is going to be products over reactants. So it's going to be CH3OH to the 1 power, and then all over CO, concentration of CO to the 1 power, because I have 1 coefficient, multiplied by the concentration of H2 to the squared, to the 2nd power. So here's my expression. Here are my my 3 equilibrium concentrations. So I'm going to put that in. So 0.35 for 0.35 there, and then for CO it's 0.15 multiplied by, and then this is going to be 0.3. So 0.3. So 0.30, and that's squared because I have a square here. So if I plug that into the equation, I get the answer. And the answer here is 26. So that's the Kc value for this reaction under these conditions. Okay, so what about this example here? So here's our second example. Here I'm given this equation. I got 2CH4 gas, methane gas going to acetylene gas plus hydrogen gas. And the conditions that they're giving me are, in the problem, they give me 0.115 molar of methane. And then the rest, I have zero product. So I'm starting with no product, and all I have is this amount of methane. So they're giving me the initial concentration of methane, and they're giving me these are the initial concentrations of my products and reactants. And the only other piece of information they give me is that they give me the molarity of the acetylene at equilibrium. So they give me one equilibrium concentration, and that's all I need. Because if I know the beginning and ending concentrations, then I can figure out the change. If I can figure out the change of one of these, then I can figure out the change of the others using the stoichiometric relationships in the balanced equation. So, so here I went from 0 to 0.035 in my product. So that's a change, that's a gain of 0.035. Okay. Here, say, since there's a 1 to 3 ratio here, then I'm going to gain 3 times that amount. So this is going to be an added 3 times 0.035, and that's going to be, let's see, 0.105. So this ends up being a 0.105. So I'm going to gain here 0.105 in my equilibrium. So this is what I should have at equilibrium. And then I can figure out the change for this one because it's a 1 to 2 relationship here. So whatever I gain here, I lose double that amount here because I'm a reactant. I'm losing in the reactant. So this is going to be 2 times 0.035, and that's going to be a gain of 0.070. And so that's going to be, that's going to be, so this is going to be a loss of 7.07. So I subtract 0.07 from here, and it becomes a 0.045. So this is going to become a 0.045 there. Okay, so once again, now that I have my equilibrium concentrations, now I can put that into the expression. So let's write out our expression. So here, the Kc is going to be equal to the concentration of H2, hydrogen to the third power, multiplied by C2H2. So the concentration of C2H2 all over the concentration of methane. So that's going to be CH4 squared because of the 2 coefficients. And so now all I need to do is plug these values into the expression. So hydrogen is 0.105 cubed times 0.035. And then divided by 0.045, 0.045, and that's squared. And so now all I need to do is plug this into my equation, plug it in my calculator, calculate it out, and it comes out to 0.020. So the final answer is 0.020 for the Kc. And so that's it for this video. This 2 problems. So this is how you use your ICE table. The problem is going to give you a balanced equation. They're going to give you the initial conditions, and then they got to give you one of the equilibrium concentrations of any of your products or reactants. If they give you that, then all you need to do is from there figure out the change, and then use the stoichiometry of the balanced equation to find the changes of the others that are missing, and then you can either add or subtract that amount to get the equilibrium amounts or concentrations of your products or reactants. So I hope this was helpful. If you like this video, please like, share, subscribe, hit the notification bell, and thank you for joining me. I'll see you next time.